Hello, viewers. This is the house of Shedo, and I am here to lead you into Math 111, a very important math course for first year students. So what we are going to be doing is for today is to look at problems under complex numbers and their solution. So please subscribe so you can get more quality videos explaining and showing you secrets to problem solving. So we have here evaluate 1 plus I over 2 minus I and express your answer in standard form. So remember, complex number is one of the numbers that we have in mathematics. Just like you have your natural number, you have your rational number, you have your irrational number, you have your integers, you have your real number, which is a very large set, and then you have what we call the complex number, which is always the number that carries both the real and the imaginary part. And as you can see here, the imaginary number is represented by your what? By your I. So this question is demanding that we should express this rational complex number to the rational form of this complex number to the standard form. So what is actually the standard form? This is the standard form. A plus IB. So this is the standard form of the complex number. So what they want us to do is to rewrite this particular form to this form, whereby we have the real part and then the imaginary what? Part. Now let's go. We have 1 plus I over 2 minus I. What do we need to do? Now, this is a rational expression having the numerator and the denominator. So what we need to do here is quite simple. All you need to do is to multiply both the numerator and the denominator by the conjugate of the denominator. What is the denominator? The denominator here is 2 minus I. And what is the conjugate of this? The conjugate is 2 plus I. So I said this times 2 plus I over 2 plus I. And this is true in mathematics because if you cancel this, you are left with what you started with. Do you get that? So this is mathematically what? Correct. You multiplying and dividing by the conjugate does not affect the original what? Expression. So we have 1 times 2, that gives us 2. Just as if you are expanding a expressions in a bracket. 1 times I, that gives us I. Then I times 2, that gives us 2I. Then I times I, that should give us I squared. Then we go here, we have 2 times 2, that gives us 4. 2 times I, that gives us 2I. Minus I times 2, that gives us minus 2I. Then minus I times I, that gives us minus I squared. Okay, now we proceed. I plus 2I, that gives us 3I. Now what about I squared? It is known in complex number that I squared is simply minus 1. This is a major fact in complex number, that I squared is equals to minus Well, a very, very important fact that comes up again and again in most of your problems in complex what numbers. So we say this is minus 1. Then over this cancels out. Then you have your 4. Then you have your I squared, which is minus 1. The minus times this minus, that gives us what? A plus 1. So what do we have? We have 2 minus 1, that gives us 1, plus 3i over what we have down, 5. Then I can split this into two different parts as 1 over 5 plus 3 over 5i. So this is exactly looking like this. The 1 over 5 is represented as what? A. Then the 3 over 5 is represented as the B. And then I have my imaginary number. So this is the imaginary part and this is the real part. So this is the standard form for this particular expression. So this is another complex number problem. We actually want to see how to obtain a value for this particular complex number with a power of 4. Remember, this complex number z is 1 minus what? Minus I. So in order to obtain the value, it is easier because of this power to work with a polar representation. So what I'm going to do is to first of all re-express this in exponential form of representing complex number, and then I'm now going to convert the exponential form to the trig form, which I'm now going to obtain the final results. Okay, to do that, remember we always need to know the value of our modulus, which is r, and we also need to know the value of our argument, which is what? Theta. So we have r is the square root once again of s squared plus y squared. So we have r is the square root of, this is the rectangular form, so x is 1 squared, then y is minus 1. So the modulus is simply root what? 2. And our argument, don't forget, rz is the tan inverse of y over x. So theta is the tan inverse of minus 1 over 1. So which is minus 45 degree, which when we write in radian form, it becomes minus pi over what? Forward. So we have obtained the argument and then the modulus. I can now rewrite this complex number in terms of the exponential form. So we have, for the exponential form, we have z is r exponential I theta. So that is the exponential form. Now we now introduce the power 4. So we have z4 is r exponential I theta always to the power of 4. So we have z4 is, what is our r? Our r is our root 2. And exponential, what is our theta? Our theta is, so this becomes minus I pi over 4 always to the power of 4. So when we do this using the laws of indices, root 2 raised to the power of 4 is going to give us 4, because it's going to be root 2 multiply itself 4 times. And then this is going to give us minus I pi over 4 times 4 is going to give us pi. So this becomes the value of this complex number in the exponential form. So I'm now going to rewrite this into the trig form in order for me to obtain the particular value of the answer. So this is now going to be written as Z4 is 4EI pi, which is now going to be written as 4 cos pi, cos minus pi, then plus I sine minus pi, or into bracket. Remember your polar representation, which is R into cos theta plus I sine theta. So that is just what we have done over there. So let's see. We have 4 into bracket. Cos minus pi is the same thing as cos pi, because cos is an even function. So we have plus sine minus pi is, sine is an odd function, so this is going minus I sine pi. So what do we have? We have 4 into, what is cos pi? Pi is actually 180 degree. So cos 180 degree is going to give us 1. Yes, cos 180 degree is going to give us, let's see, cos 90 plus 90. So this is cos cos square 90 minus sine square 90. So this is cos 90 is 0 and sine 90 is 1. So we have minus 1. So this is going to be minus 1. And then sine pi, sine 180. Let's see. Sine 90 plus 90. This is sine 90 cos 90 plus cos 90 sine 90. This is 1. Cos 90 is 0. So this is 0. Plus cos 90 is 0. This is 1. This is 0. 0 plus 0 is what? Is 0. So we have this other side to be 0. Now, you actually don't need to be doing this. I'm just using, my understanding of compound angles to quickly generate the value for this. You can punch your calculator. If calculator is actually allowed for the exam, you can punch what is cos theta, you get minus 1, and what is cos pi, you get minus 1, and what is sine pi, you get what? 0. So the final answer to this is now going to be, this is minus 1 minus 0 is minus 1. So minus 1 times 4 is going to give us minus 4, which is definitely what? Our option B. Thank you. So let's see this particular question still on complex number. Now we have the principal argument of 3 minus 3i is what? What actually is the principal argument of this particular complex number? The complex number is z is 3 minus 3i. So how are we going to obtain the principal argument? Now the first thing is for us to be able to obtain the argument of the complex number. Then when we get the argument of the complex number, we can now begin to talk about the principal argument of the complex number. And don't forget that our argument for the complex number z is our theta, which is definitely our tan inverse of y over what? X. So this is our argument for the complex number. So we have, if we make comparison with this particular representation, x plus iy, which is the rectangular representation of complex number, we see that the value of y is actually minus what? 3, which is the imaginary part, and the value of x is actually what? 3. So we have that theta is the tan inverse of y is minus 3 over 3. So we have theta is simply tan inverse of minus 1, which is definitely minus 45 degree. And minus 45 degree in radian form, don't forget 180 degree is 1 pi rad. So in radian form, we should be having 45 pi over 180, which definitely is going to be, if you divide by, let's say, 9, this is 5 and this is 20, 5, 1, and this is 4. So we're having our pi over 4. So this is definitely minus pi over 4. So this is the argument of the complex number 3 minus 3i. But the question is demanding the principal argument. So how are we actually going to get the principal argument? Now, the idea of the principal argument is to be able to restrict the values of our argument, to be able to restrict it to a particular bound. So for us to get the principal argument, we must note that the principal argument lies between minus pi to pi. So the principal argument must lie between minus pi to pi. So what we have here is minus pi over 4, which, if you observe, you see that minus pi over 4, let's write it in terms of decimal. We'll be having something like minus 0, because this is 1 divided by what? By 4. So we're having minus 0.25 pi. So what are we seeing? Is minus 0.25 pi lying between minus pi to pi? Of course, this is, if you check the number line, this is 0, and if we call this pi and call this minus pi, then definitely you see that this is actually a more bigger number compared to our pi. So it's going to be lying somewhere here, which is minus pi over 4. So our principal argument is actually minus pi over 4, because the value of the argument lies between the range minus pi to pi. Thank you. So we are going to look at this particular question, still on complex number. We have the polar form of 1 minus I root 3. And of course, we know there are different forms in which you can represent a complex number. This is actually what we refer to as the rectangular form, and sometimes I like calling it the Cartesian form. Of course, that particular form is x plus I y, which is 1 minus I root 3. So we want to see how to rewrite this particular form of complex number to the polar form. Simply means we want to obtain the complex number in such a way that we will have r cos theta plus I sine theta. So this is actually what we can call the polar form. So all that we need to do is to obtain the value of our r, which we remember this to be the modulus of the complex number, and then we obtain the value of our theta, which we remember to be the argument of the complex number. So to do that, we make use of some formulas, the modulus is the square root of x squared plus y squared. So what is the value of the x? 1. And then what is the value of the y? Root 3. So we have minus root 3 squared. So this gives us r is the square root of 1 plus 3. So this gives us 1 plus 3 is 4. And the square root of 4 is 2. So our modulus is actually 2. So let's go ahead to obtain the argument, which is the theta of the complex number. And don't forget this, that the argument, which is arg z, if peradventure we label our complex number as z, then arg z is going to be the tan inverse of y over x. So this is our arg z for the complex number. So we have tan inverse of, what is our y? Minus root 3 over what? 1. So this is tan inverse of minus root 3, which is the same thing as saying minus tan inverse of root 3, which is 6 minus 60 degree. And of course we can rewrite it in the radian form. Remember that 180 degree is equivalent to 1 pi rad. So if we use this, then we can say that our argument is minus pi over 3. So this becomes the argument of the complex number, which we can equally call theta. But then it all depends on us. We can make use of this particular value, or we can choose to say this value is negative. We need a positive value. Then if we want to do that, then we can make the argument that our arg z is theta plus 2n pi. So that is the various values we can get for our argument depending on the value of n. Remember, n can be 0, n can be plus or minus 1, n can be plus or minus 2, n can be plus or minus what? 3. So if we choose n to be 1, then we can add 2 pi to minus pi over 3, and that is going to give us minus pi over 3 plus 2 pi. That is going to give us, let's say this is, this is going to give us 5 pi over 3. So this becomes the argument that we are going to use, because this is a positive number. So the polar form will now be written up here. The polar form is now going to be z is equals to, remember the modulus is 2 into cos 5 pi over 3 plus I sine 5 pi over 3. So this becomes the polar form of this particular represented complex number. So this is a polar representation. So this is another complex number problem. We have if z is cos theta plus I sine theta, then this actually means the imaginary part. So the question is for us to actually get the imaginary part of z square, which is going to be one of these options. Now you can see that z is given to us, but we don't have z squared. So the first thing that we are going to do is to see how to obtain z squared, and then we fish out the imaginary part. So z is cos theta plus I sin theta. So as z squared is cos theta plus I sin theta all squared. So how do we go about it? This is just expansion. So we have z squared is cos theta plus I sin theta multiplying cos theta plus I sin theta. So we have cos theta multiply cos theta. This is cos squared theta. Cos theta multiplying I sin theta. That is I sin theta cos theta. Then I sin theta multiply cos theta. This is I sin theta cos theta. Then I sin theta multiply I sin theta. This is I square sin square theta. So we have cos square theta plus, now look at this, both are similar, so we are going to add up. This is 2I sin theta cos theta. And then don't forget that the fact remains that I square is minus 1. Very important. So this becomes minus sine square theta. So this is actually the square of the polar representation of our complex, because this is a polar representation of a complex number. So what we are going to do now is to see how to begin to find the imaginary part. So when you look at this, you discover that there is no I here, so this is the real part. There is also no I here, so this is actually the real what part. So this is where we find our I. So this is the imaginary what part. So the imaginary part of z squared is 2I sin theta cos theta, which is actually the imaginary part. So we can just remove the imaginary number. So this is actually the imaginary part, so which should be our solution. But if you compare this to the option, you see that there is no option that is actually looking like this. So what we are now going to do is to see how to use the knowledge of trigonometry to see how to rewrite this to look like one of these answers in the option. And don't forget, in the study of compound angles, we have that sine A plus B is the same thing as sine A cos B plus cos A sine B. So when we use this, we should have that sine theta plus theta is the same thing as sine theta cos theta plus cos theta sine theta. So finally, what do we have? Sine theta plus theta is what? Let me finish it here. This is going to give me sine 2 theta, and then you can look at this, they are the same, so you can add both of them, which is going to be 2 sine theta cos theta. So you can see that these two are equal to each other. So the right answer rewriting this expression is going to be our option A. Don't forget to subscribe. House of Shedo. Thank you.